Hello viewers, Assalamu alaikum. Once again, Makbul Islam is in front of you. Today we have discussed, we are going to learn example 15.21 page number 99. A sample of 100 observation from a population known to be non-normal yielded the sample value x bar is equal to 182 S square sample variance is equal to 299 point in approximate 99% confidence interval for the population mean. So non-normal means here, so the sample size is sufficiently large, so it is approximately according to the central limit theorem we are applying. And here, so first of all we write the given data here, solution, sample size is 100, that is given already, 100 observation. Yielded the sample values. Sample mean is already given that 182 and sample variance is given that 299. So find an approximate 95% confidence interval. So it means that here 1 minus alpha is given that 99%. So it means that we can write 99% divided by 100 is equal to 0.99. If we are finding here 1 minus alpha, that is 1 minus 0.99, so we get here 0.01. So if we uh, divide, because we are needed the 99% confidence interval for population means, so z alpha by 2 is required here. Alpha by 2 is equal to 0.01 divided by 2 is equal to 0.005. We check this value in the table, so z alpha by 2 z alpha by 2 is equal to z 0.005. We check in the table this value 2.576. See in the table. So now, as we know that the 99% confidence interval for population mean is x bar plus minus z alpha by 2 sigma s divided by n under root. Here in the question, s square is given, s square is given, s square is 299. So we are taking here s square is 200, s square is 299. So we are required taking square root on both sides. The result is given, that is equal to, what is the result? We are using calculator, so 17.29. Now substitute the values in the given interval. Now substitute the values in the given formula. X bar is already given, that x bar is equal to 182 plus minus z alpha by 2. We have already found this value. This is 2.576 and s is already known, that s is 17.29 divided by n under root, n is 100 under root. So 182 plus minus 2.576, 17.29 divided by 10. So if we subtract one time, subtract, and in the first time we are subtracting this value, so we will get here 182 plus minus 2.576 and 1.729 divided by 10, so we get the answer is that one. Now if we first time we subtract 182 plus minus 14.46 So it means that 182 minus 4.46 or 182 plus 4.46. We 27.46 or if we add this result, so 186.186.46 46 less than mu less than 186.46. This is the confidence interval, 99% confidence interval for the population mean. Thank you very much for watching. This is very easiest method I have used for each student. It can be simplified and clearly understand the example that is given. We have done. Thank you very much. Please subscribe my channel. Hello viewers, Assalamu alaikum. Maqbool Islam is once again in front of you. Today we will discuss about the question number exercise 15.2 part B, page number 118. Find a 95% confidence interval for population mean. The true mean here mu population mean of a normal population which has sigma is known and consider a sample of size is n is equal to 25 where the mean of x bar is equal to 67.53. Now first of all we write the given data. The 95% confidence in interval for population mean is unknown, which has sigma standard deviation is known, sigma is 10, random sample of size n is equal to 25, and mean is x bar is equal to 67.53. Now look here, sigma is known, but sample size is less than from 30. So we also use Z distribution. So now 95% confidence interval for population mean is x bar plus minus Z alpha by 2 sigma divided by n under root. That is the confidence interval. So 95% is given. 95% means here 1 minus alpha 95%. We can write 0.95. Alpha is equal to 1 minus 0.95. If we subtract this value 0.05. Alpha by 2 is required. So 0.05 divided by 2 is equal to 0.025. So here Z alpha by 2 we are finding Z alpha by 2. If we are finding Z alpha by 2, Z alpha by 2, Z 0.025, we check this Z values in the table of student T distribution table that is available page number 244 in this book statistical part 2. This table is the last value of the row. If infinity, this value will be available. Z 0.6. This value is available. C in the student T table in the row of infinity. Infinity row, if you check, so this value is available 1.96. So this is the value of 0.2 because Z distribution when n approaches it is sufficiently large, so you will get the Z distribution. So here we put the values in this formula. X bar is 67.53 plus minus 1.96. Z alpha by 2 we already find. Sigma is known 10. 10 divided by n is equal to 25 under root. So now we calculate 67.53 plus minus 1.96, 10 divided by 5, 25 under root 5. So we get here 2. Now first time to multiply here we get 67.53 plus minus if we multiply 3.92. First time we subtract this value 67.53 minus 3.92 to 67.53 plus 3.92. If we calculate this value 67.71.45, which is the confidence interval, we can write in the form of confidence interval. So 71.45. Thank you very much for watching. Please subscribe my channel. Hello viewers, assalamu alaikum. Once again, Makbul Islam is in front of you. Today we are going to learn example 15.21 page number 99. A sample of 100 observation from a population known to be non-normal yielded the sample value x bar is equal to 182, s square sample variance is equal to 299 point in approximate 99% confidence interval for the population mean. So non-normal means here, so the sample size is sufficiently large, so it is approximately according to the central limit theorem we are applying. And here, so first of all we write the given data here. Solution, sample size is 100, that is given already, 100 observation. Yielded the sample values. Sample mean is already given that 182 and sample variance is given that 299. So find an approximate 95% confidence interval. So it means that here 1 minus alpha is given that 99%. So it means that we can write 99% divided by 100 is equal to 0.99. If we are finding here 1 minus alpha, that is 1 minus 0.99, so we get here 0.01. So if we divide, because we are needed the 99% confidence interval for population means, so z alpha by 2 is required here. Alpha by 2 is equal to 0.01 divided by 2 is equal to 0.005. We check this value in the table, so z alpha by 2 z alpha by 2 is equal to z 0.005. We check in the table this value 2.576. See in the table. So now as we know that the 99% confidence interval for population mean is x bar plus minus z alpha by 2 sigma s divided by n under root. Here in the question s square is given, s square is given, s square is 299. So we are taking here s square is 200, s square is 299. So we are required taking square root on both sides. The result is given that is equal to, what is the result? We are using calculator, so 17.29. Now substitute the values in the given interval. equal to 182 plus minus z alpha by 2. We have already found this value. This is 2.576, and s is already known that s is 17.29 divided by n under root. N is 100 under root. So 182 plus minus 2.576, 17.29 divided by 10. So if we subtract one time, subtract, and in the first time we are subtracting this value, so we will get here 182 plus minus 2.576 and 1.729 divided by 10. So we get the answer is that one. Now, if we first time we subtract 182 plus minus 14.46. So it means that 182 minus 4.46 are 182 plus 4.46. If we for the first time we are subtract this result, so 177.46 or if we find 186.46. So that is the confidence interval. We can write in the interval form also 46 less than mu less than 186.46. This is the confidence interval, 99% confidence interval for the population mean. Thank you very much for watching. This is very easiest method I have used for each student. It can be simplified and clearly understand the example that is given we have done. Thank you very much. Please subscribe my channel. Hello viewers, assalamu alaikum. Today we are going to learn the second question number 15.24 part A, page number 115. A confidence interval is constructed a random sample of size n is equal to 50 for the mean yield of a normal population which has sigma is 21 tons. The limits for the interval are 866.11 and 875.89. What confidence coefficient was used? So now we start, come here, we start the solution. We write the given data. So first of all, we write n is equal to sample size is 50. That is sample size is given that sample size given that, and sigma is also known, that is 21 tons. The limits for the limits are given that 866 point. So that is limits for the mean 875.89. What confidence coefficient was used? Means confidence coefficient was used 1 minus alpha. Alpha is required. So from the given data we are needed 1 minus alpha. How we calculate this value? So according to the question, we are finding a confidence interval is constructed from a sample of size n. The mean yielded another population sigma is that one. The limits for the population are given. So we know that the 95% confidence interval for the population mean, as we know that 100% confidence interval for population mean is x bar plus minus z alpha by 2 sigma n under root. Sigma is already known. So now we write in the form of limits are given here 866.11 less than 875.989. We give equation number first. From here, x bar minus z alpha by 2 sigma n under root less than mu less than x bar plus z alpha by 2 sigma n under root equation number second. Comparing equation number first and second, we can write this is lower limit. So we can write x bar minus z alpha by 2 sigma n under root is equal to 866.1. Third, we give third equation. Similarly, this value is comparing with this one. Upper limit x bar plus z alpha by 2 sigma n under root is equal to 875.89. Give equation number 4. Now we are subtracting equation number first, third and fourth subtracting. So if we are subtracting, so the sign is also changed here. Subtract to each other, so this will be cancelled and here minus 2 z alpha by 2 sigma n under root is equal to, we subtract this value. We get minus 9.78. Dividing both sides by minus 2, both are cancelled. We get here z alpha by 2 sigma n under root is equal to, divide by minus 2, so we get 4.89. Next we are calculate sigma value is given that and also n is given. Z alpha by 2 sigma is known, sigma value is sigma is 21 and n is equal to, n is given that n is 50 under root and we get here 4.89. Now we calculate this value z alpha by 2, so 4.89 multiplied by 50 under root divided by 21, so we will get the answer z alpha by 2. We get 1.64, 1.645. So z alpha by 2 we get here 1.645. So this is positive. This is alpha by 2, 1.645. This is the value of z alpha by 2. So alpha by 2 if we are finding, so this area is zero point 0.5. If we are subtract this value, this is zero point 0.5 area. Zero point 0.5 minus probability of 0 less than z less than or equal to 1.645. We check this area in the table 1.6, which is the value is available in the table. It is 0.05. That is value is available in the area 0.05. So we get here 0.95. It means that here we can write hence, confident, but we are required confident coefficient 1 minus alpha is required. So alpha by 2, alpha is equal to 0.95 multiplied by 2, 1.9. So now we are required 1 minus alpha, 1 minus alpha, 1 minus alpha, 1 minus 1.9. We subtract this value. So we get 0.9 minus 9. It means that 90%. Hence the confidence coefficient was used 90%. Thank you very much for watching. Please subscribe my channel. Hello, assalamu alaikum, all viewers and dear students. Today we are discuss the next problems of on hypothesis. That test the hypothesis that the mean of a normal population with known variance 70 is 31. If a sample of size 13 gave X bar, sample mean is 34. Let the alternative hypothesis be H1, mean is greater than 31, and let alpha level of significance is 0.10. So first of all, we make the hypothesis is given that H naught mu is 31. We are test mu is 31. That is already given. So the mean of a normal population with known variance. So known variance is 70, and null hypothesis given that the mean of the normal population with known variance is 31. So we want to prove want to test the hypothesis that is already given. H1 is greater than 31 and level of significance is 0.10 and ample mean is given that 34. So this is the first step already given and the second step is level of significance. Level of significance, that is alpha is equal to 0.10 and the third we are needed here sample size also given there 13 13. So sigma is known his statistic. We are using, actually there are different types of test statistics z, t, chi square and f, but here according to the conditions, if sigma is known, if the sample size is greater than or equal to 30, so we are using z test statistics. Otherwise, if sample size less than 30 and sigma is known, we also use z test statistics. Here, since sample size hence sigma is known and n is less than 30, so we use z test statistics. Z test statistic. That is z test statistics. Z is equal to x bar minus mu divided by sigma in under root under h naught. Under h naught mean here, mean is equal to 31. So the fourth step we are using calculation. Calculation. ZC is equal to x bar. X bar is given that already given that x bar is 34. 34 minus 31 divided by sigma. Sigma here, sigma square is given that and n under root is 13. So we are taking here already square root also here because sigma square is equal to 70 and we are taking square root on both sides of this one, both are cancelled. Sigma is 70 under root. If we calculate this result, we get by calculator 1.29. 1.29 ZC. Z calculation. Number 4 step we are using critical region. Critical region. C dot R. Here is one-sided test, so we are using ZC greater than Z alpha. Z alpha. So this is one-sided test. Alpha is given that alpha is equal to 0.10. If we see the table of Z standardized table, so we will get the answer is 1.28. 1.28. Now if we check 0, so critical region is 1.28, that is Z alpha. Z alpha is greater than or equal to Z alpha, that is right side. So ZC C falls one in the rejection region, that is in the rejection region. Sixth step, decision or conclusion. Decision or conclusion. Since ZC value 1.29 which lies on the in the rejection region, so we reject is not. Since ZC is equal to 1.29 falls in the rejection region. Therefore, we reject the null hypothesis. That is H naught mu is equal to 31. It means that from this result we conclude that a 10% of people does not included in the given population. Thank you very much for watching. Appreciate you in advance. Please subscribe my channel. Hello viewers, Assalamu alaikum. We are going to discuss about the problem question number 2 from statistical book number 2 of BBA and BCS students. The marks obtained by students at a large number of colleges are known to be normally distributed with a mean we are wanted to test, that is mean. A random sample of 36 students showed an average number of marks. An average number of marks is that one, and random sample is 36. With a standard deviation is also known that by what conclusion should be drawn. It means that we are required hypothesis. So first of all, we write the given data. Given data has, we want to test mean as equal to with our normal distribution with mean as 25 and random sample of n is equal to 36 and average marks of means are x bar average 27 and standard deviation is denoted by sigma is 5. What conclusion should be drawn? It means that we are required hypothesis. So first we formulate the null and alternative hypothesis. H naught mu is equal to 25. This will be two-sided test because we are not agree, for example, so we are not agree the population mean is normally distributed by 25. And the second steps we are using level of significance. Level of significance means that here alpha is 5% almost. If alpha is not given in the question, so now we are using here z test statistic, that is third step we are using. So here sigma is known and sample size is also greater than 30, so we are using z test statistics since sigma is known and sample size is greater than or equal to 30, so we use z test statistic, that is z is equal to x bar minus me divided by sigma in under h naught. Numbers for calculation. ZC is equal to X bar is given there 27 minus mu as we are testing 25 divided by sigma. Sigma is also known 5 and n under root is n is 36 under root. If we calculate this value, so 2 divided by 5 and 6 is equal to 12 divided by 5. 2 point, if we calculate by calculator using calculator, 2.4 2.4 we'll use. For fifth critical region, ZC greater than this is two-sided test. Two-sided test we are using here. Two-sided test Z alpha by 2 or ZC less than or equal to minus Z alpha by 2. Alpha is given 0.5%, 5% means 0.05. Alpha by 2 if we are finding, so 0.05 divided by 2 is equal to 0.025. If ZC in the table Z alpha by 2 is equal to Z 0.25, we will get the answer 1.96. C in the standardized normal variable table, so we get the answer 1.96. If we are making the curve, so this is mean is 25 and here minus Z alpha by 2 which is minus 1.96 and Z alpha by 2 1.96. We check the calculated value lies in the rejection region 2.4. 2.4 lies here. Number 6, say we are using decision. Since ZC that is 2.4 lies in the rejection region, therefore we reject H naught, that is mean as equal to 25. Thank you very much for watching. Please subscribe my channel.